Alright. YouTube. Oglo the Nerd. Here we go. Mute tab. Live stream. Pop out chat. Alright, and then I copy the link, copies the linky, and then I need to send. Wait, no, video uploads. There we go. And I actually want to edit the message to add a red circle, live, and then save, and then publish. Alright, so let me also turn on music. Yep. Alright. And now, so I already kind of began on the implementation, but then I realized, wait, I can stream this. So the way this is going to work, the way I'm going to upscale audio, is I'm going to use an algorithm called the fast Fourier transform, which is a really fast implementation, like a computer-friendly implementation of an algorithm called the discrete Fourier transform, which is a digital-friendly version of an algorithm called the Fourier transform. The Fourier transform, what it does is it takes a signal and it generates a new waveform. So for those of you who don't know, sound is represented via sine waves that are piled up onto each other. And when you... Hey whale, how's it going? When you pile up a bunch of sine waves onto each other, you get sound. So a sound is literally just a waveform floating through space to your ear or whatever. And you can actually... when you put two frequencies together, like if you want to play two frequencies together, you add two sine waves together. Let me open Desmos. So let's say you have a sound. Here's I'm just making a helper function here in Desmos. Say you have a sound that is one sec. So let's say you have a sound that is going at it's full amplitude, so full volume, and it's going at 4 hertz, so 4 times a second basically, at a phase offset of 0, and then you just pass in time. And I can change the frequency and whatnot. So this is a 2 hertz signal. Now if I wanted to play 2 frequencies at once, like 2 audible frequencies at once, literally all I have to do is add up 2 samples. That's it. So, boom. Now if I were to play this through a speaker, if humans could actually pick up audibly hertz this low, 2 hertz and 4 hertz, then what you would hear is very basic, just a sine wave tone. You would hear a 2 hertz wave and a 4 hertz wave playing together, but in reality it's just one waveform. Sound is really cool. And I can also like change the phase offset and whatnot to change the shape of the wave. Which, fun fact, a cosine wave is literally just a sine wave with a phase offset of 90 degrees. So 90. I can show you guys. Sine, amplitude full, frequency 1, phase offset 0, x. So this is a sine wave, and you can see like it starts at 0, then goes up, then down, and then ends at 0 for the second. But if I phase offset 90, now it's a cosine wave. Or rather, not too sure what happened, but it's supposed to be a cosine wave. Perhaps if I... Yep, this is the rainy. Yeah, it sounds great. I love it. So that's basics on how sound works. Now, in reality, when you play sound in a computer, let me actually bring back those functions. So here is my wave, and I'll get rid of phase, or actually I'll keep phase, but I'll define a wave function that takes in t, and it's just equal to the sine function with t. And what I'll do is I'll create this wave visually. And then what I'll do down here is I'll create a slider. I'll call it S69 for sample rate. And it will go from 1 to 75, for example. And it will go in steps of 1. So now I have my sample rate slider. And I can draw sample points. So I'll explain this in a bit too. So I want to create a Desmos point, and I want to go from 0 to 1 divided by S69, all the way to 100, for example. And then I want to, for each one of these points, I want to put in the same thing. So now I have these samples. If I change the sample rate, you can see how the samples match the wave. And when you create audio, you cannot represent a wave with infinite precision. Thus, you have to take samples of the wave, and that's where the term sample rate in the audio world comes from. And that's where all the fuss comes from of like, what's the best sample rate to listen to audio? And there's also something called the Nyquist frequency, where the Nyquist frequency basically says, or the Nyquist theorem, sorry, basically says your sample rate has to be at least twice the frequency of the highest frequency waveform. And I can show you, like, this is a wave at 1 hertz. If I set the sample rate to 1, you can see everything just zeroes out. 16. There, now you can more clearly see the samples. So everything zeroes out at a sample rate of 1, but if I bump this up to a sample rate of 2, it actually still zeroes out because I got catastrophically unlucky with the phase offset. So that's why oftentimes you go a little bit above the Nyquist frequency, or the Nyquist theorem. And you can sample your audio, and oftentimes audio, since the highest we can audibly hear is around 20,000 hertz, oftentimes sample rates, the lowest sample rate you would ever use is 44.1 kilohertz. And oftentimes if you want good audio, you either have to do 48 kilohertz or 96 kilohertz. 96 kilohertz is more of like an audiophile territory, and then there's also 192 kilohertz, which is absolutely overkill, but some people swear by it. Yeah. Hi, how are you? I'm good, how are you? Are there even many sound upscalers out there? Yes, but from what I found, they all jump to AI as the solution. And see, I actually know how to upscale audio without using AI, so I'm out here and I'm like, you know what? Fuck that. Fuck all those websites that use AI. I'm just gonna write my own command line interface audio upscaler. Here I am. And you know what? I'm gonna do it in C without AI to prove to those bastards that it can be done without AI. So I'm gonna do that. So I already kind of started writing it a little while ago because I was having trouble with getting OBS working. Why would you use AI? No, it's not, because the thing is, AI is, I don't really know how to explain it. I guess this is how I'd explain it. GIMP. So, let's say you have your wave. I know, terrible wave, but see, with using the fast Fourier transform, you can upscale, or actually, I should draw the sample points. So you have your sample points on your wave. And essentially, what these sample points mean is anything in between them, that information is just thrown away. So when you use an audio upscaler, if you use one that's using the fast Fourier transform, first it runs this signal through the fast Fourier transform, which is just a computationally friendly way of doing the discrete Fourier transform with some caveats. Like you have to pass in an array of samples that's a length of a power of 2 for the fast Fourier transform. Because it's a divide and conquer algorithm. You'll see that later. But let's say this frequency, this wave's frequency is at 5 hertz. Well, the fast Fourier transform will return new samples, same length and everything, but it will return basically what frequencies are in the passed-in signal. So 0 hertz, 1 hertz, 2 hertz, 3 hertz, 4 hertz, 5 hertz, 6 hertz, etc., on and on and on. This is what the output of the FFT would look like. And you can see this spike will tell us about this frequency. 1, what is the frequency, which we can figure out by where in the list it is. 2, what is the magnitude, which we can figure out by using the Pythagorean theorem to, you'll see later, but it does involve complex numbers with real and imaginary parts, etc. And then the phase can also be found with an inverse tangent and whatnot. Yeah, so what the fast Fourier transform does is it actually figures out what frequencies are in a signal. And then what you can do when you audio upscale is just throw away the original signal and recreate it from whatever the FFT output is telling you. Whereas what AI is going to do is it's going to take a best guess about what is in between these samples. So the upscaled audio might actually sound something like this. Like, it's not going to be quite consistent. And that's why I think using AI to upscale audio is a horrible idea. Is because you can already do it without any inconsistency. All you need to do is just use this beautiful mathematical formula. And, like, I mean it, if you upscale the audio using an FFT, your upscaled version is literally perfect. That's the most amazing part to me. It's literally perfect. There's no error whatsoever. Yeah, so I have, my mom took away my laptops for a while. So I used her laptop to code up a sketch on P5.js, where I was learning about the FFT and stuff. And as you can see, here's my waveform down here. And here's my waveform down here, and then the upscaler, or no, not up, the FFT tells me what frequencies are making up that waveform. So I have a frequency of 1, 10, 17, 20, 50, and the height of these peaks also corresponds to the magnitude of the wave being added onto each other. And as you can see here, I have those exact frequencies in the wave spec. And here's the DFT function, which calculates the DFT, which is the slow version, essentially, of the FFT. And yeah, so I just have a bunch of this stuff. It's just a JavaScript thing. I hate JavaScript. What's the AI way of how it's doing upscaling? I don't actually know, but in general, I do know how in general AI works. Obviously, if you get into specific applications like audio upscaling with AI, there's gonna be some extra stuff you tack on, but at a starting point, AI is basically just a neural network. So a network of nodes, essentially, where you pass an input and train it to give a certain output based on a certain input. And the problem with that, though, which I don't want to really get into AI right now, but AI, it has a lot of moving parts. Yeah, so AI has a lot of moving parts, and the thing with AI, though, is it's not very deterministic. It's not very deterministic. So if you, for example, want to make a logic gate using AI is not going to do perfectly because it's not meant for like cut and dry stuff like logic gates. Whereas audio upscaling is actually kind of cut and dry, so that's why you don't want to use AI for it. Yeah, something like that. Maybe. I don't know. I don't really study AI, but I've studied enough to at least know where people start. Yeah, so use an FFT. If you upscale audio, don't use AI. It's not perfect, whereas an FFT is literally guaranteed perfect. So yeah, I guess let's start programming this. I made a sketch, or not a sketch, but a little C file. Like I said, I already started programming this before I started streaming because I was actually playing around with Sway and I couldn't get OBS to work. So, but yeah, I have so unsigned long, or actually OFT lib uint max t a number oft lib uint max t b number -1, and then I just want to return n not equal to 0 and a b 0. So this is a function that will just tell me if a number is a power of 2. Yeah, no worry, Calamari, it's fine. No worries. Let's see. Yeah, so that's my power of 2 function. And actually, I could, I'll just say inline, just for some implicit optimization. So, yeah, power of 2. And then I need a function that generates a number that is a power of 2 that is either equal to the number passed in or more than it. So I'll go down here and I'll do that. I'll say if, because I think the algorithm here might be a little computationally expensive. What do you mean, where's n? The n variable was in a different C file that is completely unrelated to this. If number, so if OFT_lib is PO2 number, if number is already a power of 2, I want to return number. And then I want to say OFT_lib uint max t I, yeah, I is 1. And then I want to say while true, if I, there's got to be a better way to do this, honestly. Here's what I'll do. I'll go back into that is power of 2 po2.c, and I'll create a function. I'll create a function that does what I want. So unsigned long gen po2 bigger or eq. Unsigned long n I'll say, let's see, so n, if n is a power of 2, it will look something like this, the binary layout. So a power of 2 is characterized by a binary layout of only 1 somewhere. That's what a power of 2 is. And what I need to do is figure out, so let's say, let's see. Here's a not power of 2, for example. Yep, so this is not a power of 2. Let's see, what would this number be? 1, 2, 4, 8, 16, 32. 4 plus 32 is 36. 38. This would be 38, which is not a power of 2. Hello, Noah, how's it going? And this will be 1, 2, 4, 8. This is 8. So I need to figure out, I think the way this algorithm is going to work is I need to figure out what the biggest power of 2 in here is, I guess. So how can I do that? I'm thinking, I basically want to extract this. So I'm going to write this function where if is power of 2 n, return n. Didn't know you were live, no revolt ping. Yeah, I stopped using revolt because it sucks. Also, you can't at everyone or anything like that in revolt, which is annoying. I'm back on Discord since I have to use it anyway. Thank you. Yeah, it's the Rainy 75. I recently got it. I absolutely love it. Also, Thinking Freely, you seem new. Welcome. Yeah. Ooh. There we go. Sorry if you get back on this. I mean, n returned shouldn't be number. Where's it? Oh, did I make a typo? Yeah, I made a typo. You saw it. Thank you. Part of me hates auto-tilers, but part of me loves them. Right, so yep, there's Noah right there. I'm gonna turn on Do Not Disturb just for the stream. Do not disturbo. Right, so what would I need to figure out how I can pull out this one. So just isolate this one but set all these to 0. I think maybe if I do, I'm gonna process this. So I'll do like let A is equal to not PO2 minus 1, which this would then be 0, 0, 1, 0, 0, 1, 0, 1. And then let B is equal to not PO2, which would be 1, 1, or 1, 1, 0, 1, 1, 0, 0, 1. And then if I OR these, let's say, so A or B, 1, 1, 1, 1, 1, 1, 0, 1. No, that's not gonna work. What about if I XOR? If I XOR these, then the result is 1, 1, 1, 1, 1, 1, 0. Dang it. How about if I AND 0B 0, 0, 0, 0. God. Okay. I basically need to find a way to get this one out. Yeah, I want to yeah, exactly. I want only the most significant one in the number to be left, whereas every other bit is set to 0. So, yeah. Let's see, how can I probably could search for an algorithm online, but I don't really want to steal other people's work. Yeah, let's see. How about if A will be not PO2, which will be so that's the not. And then, let's see. Then I want to start by chopping off these bits. So what if I say let b is equal to not PO2 minus 1. And then I can say let C is equal to A and B, but also or. No, that's not gonna work. You know what? I am going to look online just to see. Pulling the most significant binary digit out of a number. What the fuck is this? C. Oh. Python. I love that interpreted languages are in here. We're talking about most leftmost, most significant, meaning most influence. So the rightmost one is the 1-bit, whereas then to the left of that is 2-bit, to the left is 4-bit, 8-bit, 16-bit, 32-bit, etc. So I'm trying to find the biggest one that is set. Set bit number, if n is 0, return 0, int MSB. What the fuck is this? So I'm dividing n by 2 while n is not. Okay, I'm just gonna use a loop. So, okay. While n unsigned long n bits is equal to size of n times 8. So this will get the amount of bits in n, which I can actually store in a 8-bit number, unsigned char. Now, while n shifted over by n bits minus 1, so let's say let's say here, and the bits is 4, 1, 2, 3, yeah, okay, so shifted over by 1. While that... Did I do this right? No. So while this whole thing is... And I want to do... and 1. So while this whole thing is equal to 0, do n 1. Or wait, no. I want to shift left. You don't, bro. Zozing is sodding. Rexim. This guy. It's sodding. Yeah. Bruh. What do you mean he is so annoying? He's one of my favorite streamers. Huh. When did that get in there? Must be good. Wait, no, that's not what I wanted to do. Let's see. Yeah, he's very based. Let's see. Oh, wait, yeah. Shifts 0. So, okay, let's say this is a 64-bit number. It means I can shift 64-bit 64 times at most. Yeah, an unsigned char can store that. Shifts 1. Or shifts plus plus. I like that. Okay, what is wrong here? Oh. Wow. Okay. Interesting. I'm glad I'm glad I got warned of that. Shifts, and then some of his projects actually do have meaning, and also even his pointless projects. He's a recreational programmer. He's not trying to make useful stuff all the time. He's just trying to enjoy programming, and I like watching that. I try and do the same, but I at least try and make useful stuff for me, since that's what gives me motivation. Yeah, he codes for fun. Or rather, programs for fun. Never call programmers coders. It's actually kind of mean. I can explain why. It's basically because programmers focus on logic and reasoning, and don't focus on one specific language, whereas coders are, this is the best way to calculate this in JavaScript, or this is how you do this in Python, yada 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 yada. Coders focus on one language and one language only, or a set of languages. They're not focused on the overall way to do things. They're focused on how to do stuff in a language. So they're very limited, whereas a programmer focuses on algorithms and stuff as opposed to a specific language. For a programmer, a language is just a means to an end. They could switch language whenever they want to, learn a new language in like 24 hours at max, and be on their way. So that's why never call a programmer a coder because it invalidates what they're able to do. One, this is not Vim, and two, I hate relative line numbers. They're distracting. I like seeing my absolute line numbers as well. Which I guess does at the cursor. But yeah, for my workflow, I never make huge jumps in my source files. I either use the mouse to scroll or I go to specific line numbers. Dude, Noah, you're crazy. You say at least one crazy thing in every stream. Some shit like you disabled line numbers. Bruh. Yeah, this is Helix. Right, so now I got to, now I gotta, return, let's see, so return, return n, and unsigned long shifts, and most powerful shift by shifts. And I also want to -1 from shifts. Yeah. Most powerful will just be set to unsigned long. Most powerful will be set to unsigned long 0. And degenerate chat's your home. But you barely send anything in degenerate chat, from what I recall. Most powerful. So I'm anding, and then I'm gonna XOR. No, most powerful. I'm actually gonna call this max. Max. And I'll say const unsigned long most powerful is equal to max XORed by max shifted over by 1. So this is going to essentially say bitwise math is a lot of fun though. I like doing bitwise operations. It's one of my favorite things in programming, which is one reason why I gravitate towards compiled languages. Some XORing. Yeah, so this will now be most powerful. And I'm shifting over, say, shifts are 1. Yeah, so this should be the final number here. And I can actually test this. Unsigned long unsigned long number will be oh, I should also say if number is equal to 0, return 1. If n is equal to 0, return 1. Thanks. Yeah, I'm yeah. Yeah, the keyboard is the Rainy 75, and then this rice is just a Hyperland rice I made. It's Hyperland's a lot of fun to rice. And for those of you who want to create custom Hyperland animations, this is a side tangent, but it's actually really easy. Hyperland.conf animations. Essentially, all a Hyperland animation is can I copy that? Cat head lines 44, tail lines 1. Yeah, so all a Hyperland animation is a God damn it. I'm being called on Discord again. So all a Hyperland animation is a cubic Bezier curve. So if I have a cubic Bezier curve like this, for example, then my animation will start out slow, go fast, then go slow again. That's all a Hyperland animation is. You just plug those numbers into your Hyperland configuration and boom. Alright, so now I gotta test this. So my number is 0. And let's see. I'll actually do another loop. This time a way smaller loop. I'll just get rid of this. I'll say, alright, see ya, Maga, have fun. I'll say up to 1,000. I'll do printf. Printf is PO2, and I'll say it's a string, and I want to say this string is equal to is PO2 I. Yes, I love ternaries. It's one of my favorite C features, which I wish more programming languages had. I don't understand why they're called evil, because they're really useful, like actually really useful. Let's see. Is PO2 number LU gen PO2 and this will be I gen PO2 bigger or EQ. So there we go. Now if I So, of course, it's the JavaScript devs. po2, po2.c. So now if I run this, wow, it's quick. Well, I'm only doing 1,000 entries, so. But I'm not, oh, okay. So anywhere where it's already a power of 2, it's returning, but why is it returning 0? Let's see. Let me move this to another workspace for now. It feels kind of claustrophobic. Right. Okay, so gen po2 bigger EQ. Is there something wrong with... So I'm saying I'm getting the bit on the very end. And I'm saying and that bit with 1, so it's only that bit. And then I'm saying while that bit is 0, so while the very end bit is 0, shift 1 over, shift n by 1, and then also increase shifts. And then let me actually just print out. Shifts is LU N LU shifts N. Yeah, it took me a while to figure out how the hyperlane animations were actually done. I think I actually had to. I think I actually ended up speaking to Vaxry. I have him in my DMs, so sometimes I'll just crap over a question into the DMs, which he's not always happy about because obviously he's a project developer and having questions asked constantly can get annoying. So I try and be relatively, like I don't ask him many questions, but if I get desperate, I do ask him. And I think I asked him, like, hey, how do you configure hyperlane animations? And he told me something along the lines of, oh, it's a cubic Bezier, you dumbass. Which he talks like that sometimes, it's funny. But yeah, so took me a while to figure out, but I'm glad I figured it out. So, why is N? Oh, it's because I'm shifting. Right. Is there a place where it's not 54? Shifts 62. Okay, that makes sense. Yeah. So it appears that shifts is working correctly. And then I'm getting the maximum number for an unsigned long here. And I'm saying the most powerful, so basically biggest power of 2 that this unsigned int type can store. So most powerful will be max XORed with max shifted over by 1. Which, in theory, would mean if this is the maximum, I shift it over by 1, then I have something like this, and if I XOR it, then I get... Wait a second. No, screw that. I could just do this. Max shifted over by 1, and then not it. Okay, cool. And then I'll just GCC that. PO2. Still not getting anything. Did I do something wrong in my print statement? No, I did not, because it works whenever it is already a power of 2, so. What about... Let me revise this a little bit. Shoot. Unsigned long new PO2 is equal to... Oh. I see my problem. So in theory, this will now work. No, it does not. Why? Unsigned long new PO2 and old. And I'll say new PO2 is equal to new PO2. I'll say I want to const unsigned long NPO2 will be most powerful shifted over by unsigned long shifts. Hello log void, how's it going? You seem new. Welcome. So, okay, I'm shifting over most powerful by shifts. Okay, yep. So, now NPO2 will be equal to whatever the most significant one in N is. I'll actually, instead of doing N old, I'll do, So there we go. And then I'll say N. And most powerful shifts NPO2, no new PO2 is N. or NPO2 rather. And then I guess I can just say that new PO2 is NPO2 shifted over by 1. Return new PO2. Is that it? What's up, NA? How's it going? Okay, now it looks like I'm getting something. Well, I'm working on an audio upscaler. Eight, 16, 32, 64, 128, 256, 512. Yeah, yeah, it's pretty fun so far. I really don't think I've had unfun programming sessions, unless it's like in JavaScript or something. Like, I pretty much just enjoy programming in general. Water reminder. Let me bump up the... I'm gonna test this. Well, it's fast. Really fast. That's good. I think it's actually faster. Wait, no, that's impossible. I thought it was faster than my isPowerOf2 function for a second. But then I realized, oh wait, I am using my isPowerOf2 function in this genPowerOf2 function. What does califragic mean? This is gonna take a while to run, so... Ah. Hehehehe. Let's see. ftlib is power of 2. Yeah, now I got to just convert this into that. So I'm going to say if number is equal to 0, return 1. And then I want to say, yep, that and const oftlib uint max t, or actually oftlib uint 8t, or ubyte byte t. Uint min t. There we go. Sometimes I hate that C has these weird int types. And I'm not going to include std int because I want this library to be a single header library, so, and I don't want to include anything from the standard library, or include anything at all, just this single header file. Yeah, so unsigned integer big enough to store. Oop. Biggest, smallest. There we go. Almost forgot my charger in my pocket. Nice. Glad you found it. I think. Right? It's a good thing you found it, right? N bits size of n times 8. oft lib uint min t shifts 0. And then I want to do oft lib uint max t temp is equal to number. And then I want to say while tmp shifted over by oft lib uint max t and bits shifted over and then minus 1. I'm gonna go outside that and I want to say and 1 is equal to 0. So I just put that in there. Yep, okay. And then I want to say while this condition tmp shift over by 1 shifts plus plus. Const oft lib uint max t max is equal to oft lib uint max t 0. Just like that. Const oft lib uint max t max po2 max 1 shifted over by 1. Yep. Okay, and then I want to say number power of 2 all right, const npo2 oft lib uint max t npo2 max PO2 shifted over by shifts. Yep, shifts. OFT lib uint max t shifts, just like that. And I want to say const oft lib uint max t new po2 is equal to n po2 shifted to the left by 1. And then I want to return new po2. Return new po2. So now I've got this in my code. And then I want to, okay, so I got this implemented. I also want to, all right, let's start by implementing the DFT, I guess. So, yeah, I feel like, so this stream, while working on oftlib.h, it's going to be a lot of just copying and pasting, essentially, of what I already wrote. But the audio upscaler, this is a fast Fourier transform library that I'm working on right now, but then the audio upscaler will use this header file to get this functionality, and then that will be me purely making just a simple program in C that reads audio files and whatnot. So I'm gonna move here, and then I'm gonna go here. I'm gonna say, what did I do here? So n is just, I'm gonna create this n because that's how it's formally done in the math spec too. oft lib uint max t n is equal to input count. Yep. And then I just want to say okay, so I have my output array here, and output is going to be the same size as input. And I want to say for oft lib uint max t k, k is 0, k is less than n, k plus plus. I want to say let sum, or no, not let, complex oft lib complex number sum, complex number sum, and how did I lay it? Yeah, real imaginary. So I can just say 0, 0. And I made those doubles, right? Yep, doubles. And then I'll just say, I like this. I'll say for oft lib uint max t n, n is less than capital N, n plus plus, and this portion is the actual, like, pulled from the DFT spec. If I search up DFT, what's actually represented here, up here, this is this for loop. So I want to say x is equal to x is equal to oft, no, it's equal to oft lib complex number oft lib complex number x is equal to input n and then const angle will be okay, let's see. I agree. Yeah, I hate math notation. It's not until I see that math translated into code that I actually understand it. Angle. Though I at least exhibit the basic skills needed to translate most math expressions into code. It's just not until I look at that code that I can internalize what that math is doing. Nope. I'm 16, haven't been to university yet. I just use YouTube and Wikipedia, really. And then occasionally if something is like really boggling me, I'll use AI to help explain it to me. Because AI is like speaking to a human, whereas tutorials, it's they kind of have to cram everything in there, and you can't ask questions to the tutorial because it's a pre-recorded video. So yeah. Inverse. But I never copy and paste AI code. That's one thing I'm very proud about in my life, is that I do not copy and paste AI code ever. I don't even use things like Copilot. I refuse to. oft lib pi. oft lib pi times k double k times double n. There we go. So, okay, that's the angle for the sine function. Yeah. Welcome back, Noah. How's it going? This is gonna be kind of annoying. I've never written a sine or cosine function from scratch, and I also don't want to include math.h. Is it? You know what I could do? I could just... I'll have a macro, you'll see. Const double ocos will be oft lib cos. Oh, yeah, because a cosine is just a sine wave, but offset by 90 degrees. Yeah, I know about that. Oft lib cos. Oh, shit. What did I do? Okay, there we go. I wasn't looking at the screen. Angle const double O sine oft lib sine angle. And then up here, let's see, define oft lib implementation. I'll say if not defined. Yeah, I'll expect the programmer to define those. oft lib cos and oft lib sine. I'm not gonna use a lookup table. also, like, I'm doing it with macros here, so then whoever's using this library can decide how they want to do sine and cosine. I'm not going to overcomplicate this library just because the fast Fourier transform is, like, even though it's the fast version of the discrete Fourier transform, it is a tiny bit slow. And the performance cost of a sine function versus the entire FFT is so minuscule it practically doesn't exist. So having a lookup table for something like this is so not needed. But it is something that, like, if that's what you're thinking, then you're probably a good programmer if you're thinking about lookup tables for performance. Plus equal x real times O cos. So yeah, I'm just, I'm multiplying a complex number, right? Yeah. I think. I don't know. X imag times O sine sum imag plus equal x dot real times O sine x dot imag times O cos. There we go. I never did so low level coding. My biggest achievement was COBOL program to C#. I mean, I've never programmed in COBOL before, and I've only programmed in C# briefly when I was, like, years ago, a Windows user trying to use Unity, but that's about it. Well, if you get into low-level programming like C, it's really not bad. C is actually a pretty easy language to pick up. The only hard part is knowing the exceptions that come with low-level programming. Like, for example, arrays. Literally all an array is it's not a data type per se. It's a pointer to a block of memory reserved for, like, that has enough space for however many elements are in the array. So that's why, like, if you ever try programming in C and you hear the term arrays decay to pointers, that's because arrays aren't arrays, they're already pointers. It's just when you pass an array to a function as a pointer, the function that is reading the array doesn't have compiler features like size of that work properly. So that's why a lot of functions will expect you to also pass in the array size. Yeah. So when you get the length of an array in C, all you're asking the C compiler for is the size of the block of memory in bytes that the array points to, divided by the size of the data type of the array in bytes. So, and also you also have to learn about the stack and the heap. Once you learn about arrays, stacks, and heaps and pointers, you can pretty much master C. Yeah, like literally all an array is just reserved space in memory for elements to be squashed together in sequence, and then the array variable itself is just a pointer. It's quite simple. That's why, like, here I'm expecting an array to be passed into this function, but I'm actually expecting a pointer. Exactly. Yeah. So C is really, like, the actual language itself is dead simple, but where the tough part comes in is when you actually have to program in C and understand how stuff works on the CPU level and memory level. Yeah, I'm probably gonna stream working on my compiler some more tomorrow, or maybe even later today. Oh wait, that I want to say if inverse sum.real divided by double n. So this is for the inverse Fourier transform. What exactly do you mean by on the CPU level? I mean, maybe that's not the best wording. I just mean like it helps. Mainly it's on the memory level. Like you just have to understand how the stack and the heap work. That's like the two main things you have to understand if you're programming in C. But it also helps to understand how stuff works on the processor level. So like it helps to understand how the processor processes pointers and stuff. I guess. It's a little hard to explain. Basically, you just want to learn how a CPU executes stuff if you're programming in C. So like you want to learn about what an instruction actually is, how the instruction is processed, decoded, how the CPU yeah, it's a rabbit hole, so I'm not going to explain it in detail, but yeah, you just want to understand how the CPU does things. And it's not hard at all, really. It just boils down to a giant pattern matcher, essentially. The CPU just reads the opcode for the instruction, figures out which instruction corresponds to that opcode, takes the arguments out of the rest of the instruction and does stuff in the background, like with the ALU and memory and whatnot. And also segmentation fault, for anyone who doesn't know. A segmentation fault is when a pointer's dereferenced and that pointer points to memory that the program is not allowed to access. John Carmack. John Carmack's the guy who created Doom, correct? Yeah. Yeah, I really like the fast inverse square root. That was really cool when I learned about it. And it uses undefined behavior, which just makes it even more of a badass function. Let's see, and then I don't need to return anything because, yeah, I'm just writing to a pointer. So this is the DFT implemented now. I should test it. Okay, so I need to mkdir test, cd test, touch, or mkdir src, touch src main.c. And I'm gonna make this a CMake project, just because I can, and also because it's cross-platform, of course. oglolib cmakelist txt test. Get ignore test. cd test. Get ignore. Make lists. I want to say oft, or just call it test. Can I just do that? CMake stuff. Create library, or I want to create executable, not just a library. Add executable. Project name, static, don't need that. Add compile options, target compile options, private name, yep, okay. So that's the basic CMake. Then I just want to write a simple hello world to make sure this works. Int main void return 0 printf hello world \n mkdir build cd build cmake make test. All right. I have both. So I got into programming because, well, actually sort of got into programming for one, a role model, and two, for an ambition. I got into programming about I want to say 6 years ago. I got into programming 6 years ago because one, I wanted to create a video game, and two, I was inspired by Notch. Nowadays, my role models are I'm inspired a lot by Sodding. He's one of my favorite programming streamers. And then I also still want to create my own video game. Later on, I found out that Notch, even though he's a genius game designer and game creator, he's not really the best programmer ever. His code's actually hot garbage. Yeah, it's Sodding. I'm surprised at how many people haven't heard of this guy. This guy. Funny Russian man. Ah. Yeah, I love his stuff. Like, if I'm bored, I'll just sit back on the couch or something and watch one of his streams. Yeah, it's great stuff. His channel's great. Highly recommend. Include... I want to include oftlibh. There we go. Yes, nice, fun, and educational. Exactly. I actually, to give an idea of how simple C is, I figured out I actually knew the entirety of C when I started programming in it after I got fed up with Rust. And I think the reason why is because I've watched a ton of low-level learning, which he rebranded to low-level TV, but I've watched a ton of low-level learning and sodding, and I've also learned about how the CPU works. And just from all this random cobbled together knowledge, all of a sudden I was like, holy shit, I actually know C. Because C is so simple. It doesn't have any like weird paradigms it forces you in and forces you into or anything like that. It's just basically a pure abstraction over assembly. Okay, so hello world is working correctly. And now I'm going to include math.h. Define OFT lib sign will be sign. Define OFT lib cos will be cos. Yeah, C is extremely simple. I tried Rust out and man, I really didn't like its approach. I can see the point, but I really didn't like it. Yeah. So I actually really like Rust. It's one of my favorite languages, but I agree. Manual memory management feels really good. I like Zig's approach with a defer statement. I think that's, like in my programming language, that's what I want to add as a defer statement, but no drop trait. However, I do really like traits. Rust's approach to generics and Rust's alternative to OOP is really nice. I love Rust for that. I also really like that Rust has tagged unions, just implemented in the enum type, as opposed to a struct, a union, and an enum all merged together into an unholy amalgamation. I tried programming in Zig, but Zig is not even 1.0 yet, so even the syntax is changing, and the compiler is not meant to be backwards compatible yet. So I'm trying to avoid Zig, at least for now. Zig is also, I just don't really like writing it. The syntax kind of sucks. I do really like, though, how Zig, all the memory allocations, like it tries to prevent ghost allocations, so you control like what allocator stuff uses and whatnot. I also need to look into Zig comp time, because I've heard a lot of good things about that. I'm thinking in my programming language I'll have a few different kinds of macros. I'll have C-style macros where it's just like a copy-paste syntax, because C-style macros, the simplicity is really nice sometimes. And then I'll have like Zig-style macros where you can write macros using my language. Maybe I'll also have Rust-style macros where it's like a specific language that's very specialized. I don't know. I want compile time programming to be a strong point in my language. So okay, I want to create some samples. I thought I saw C418 for a second. The way I'm going to do this, I'm going to include stdint.h. I also just realized I should include these underneath this, and only the necessary stuff will be included up here for this. stdioh. I want to say uint or double No, I need to do OFT lib complex number samples sample rate times duration seconds. Define sample rate will be 100. Define duration seconds will be 1. And then so this is samples. Yep. Okay. And then I'll say for size t I 0 I is less than sample rate times duration in seconds I plus plus, I'm gonna say double time is equal, or const double time is equal to I double I divided by sample rate. Like that. And then I want to say samples I is equal to sine. I want to do 2 times pi OFT lib pi times 2 times pi times frequency in hertz times time times amplitude. And I'll just define those. I'll say const double frequency in hertz will be 5. Const double amplitude will be 0.7. And now I just need to define OFT lib pi, and I'll define that up here as OFT lib pi digits of pi. So I'll just copy a bunch of these. And I'll delete, like, up to there. Maybe there. Yeah. I've worked as a programmer from 1999 to 2000. Yeah, modern languages are a lot more complicated, and they have all these stupid paradigms and stuff. Like, oh, OOP, functional programming, and I don't really like the modern programming landscape, which, you know, is a little weird for a 16-year-old to say. Oh, sweet. We have people my age in the chat. Let's go. Oh, by the way, that reminds me. I have a Discord server if you guys want to join. invite link. Alright. Real, imaginary. Okay, so that generates a signal, and then I'm just storing it in my samples array. And then I just want to say, and also just put down here, size t samples count is equal to size of samples first element samples, and that will get the length of the array. And then I just want to say I could also define a macro. That's usually what I do. Array len x is size of x divided by size of x0. So then instead of this, I can just do array len samples. And then I can say oft lib complex number ft out will be the same thing. You'll be array len samples, like that. 35 years? Hey, that's pretty dang good. Well, see, the reason it may, like, I don't know what your skill level is, but if you're saying my skill's higher, I would say the reason that may be is because we just focused on different things. Like, I'm focused on complex algorithms and compilers and stuff, whereas you might be focused on something else. oft lib dft. I want to pass in samples, ft out, and array len samples. Yeah. And I also want to say that this is not inverse. So this is not the inverse transform, this is the regular transform. And then I guess I just want to print out all of this for size t I is less than array len samples I plus plus. And I just want to, in here, say printf, and I'm going to print a complex number, so f plus fi, yeah, and new line, and I'm going to say ft out I real, ft out I imag. So I'm going to print out the output of the DFT. Make, what did I do? make, what did I do? Ah, classic, okay. Size of, instead of n, it's number. Make, what did I do? Ah, CMake list txt. I want to compile. I want to link libraries, and I want to say math target link libraries, and I want to say project name private M for math. Make test. Right, so now I have a bunch of complex numbers, and they all must be really, really small, because, yeah. You guys see it too. So either I fucked something up, or I don't know. It does seem to work, because, yeah, the Fourier transform output is actually mirrored, interestingly enough. So it does seem to work. Here's what I'll do. Let me just increase what this is allowed to print. 20? This is how you do it, right? Make. Test. Yeah, okay, so now we're getting something. And then we have -35 here. So now I can write a function to extract information out of that complex number array. So I'll write down here, I'll say OFT_lib wavespec, OFT_lib extract wavespec, and this will take in a complex number. Ooh. X, and it will also take in OFT_lib uint_max tk, takes in a complex number at index k in the index k in the transform output list, and spits out information on the waveform at a specific, and spits out waveform information, frequency, magnitude, phase, and I'll add etc. just to be safe, so I don't have to update the documentation. Now I have to create OFT_lib wavespec. Typedef struct oft lib wave spec. And this will hold a double frequency hertz, double magnitude, frequency, magnitude, phase offset, frequency of the wave, magnitude of the wave, phase offset of the wave, right, and then now that I have this, yeah, so that's my wave specification. And then time to implement this function. Which I'll do down here. And I will yep, come over here. And I will go down to FT out to wave spec. Yep, down here. And I just want to say, oh, not let, oft lib wave spec. Spec is equal to, I'll just leave it like that. So spec return spec. So that's how it will be done. And then I'll say spec dot frequency hertz k times, oh, right, I actually need more information. I need the length of the output list and the sample rate. Oft lib uint max t sample rate, and oft lib uint max t ft out count. And now I just also need to reflect this in the actual function definition, or like header. Yep. So then back down here, I'll say k times the frequency is double k times double what was our sample rate divided by double n, and n is just the ft list count. So that's what the frequency is, and then the magnitude is just the square root oft lib sqrt, and it's x dot real times x real plus x imag times x imag. So I'm squaring that. And actually I'll write a simple macro just to make this pretty. Oft lib square plus oft lib square. And I'll say x real x imag. Implementation, oft lib implementation, define oft lib square. X times x. And I'm also dividing that by ft list count. That's not actually in the spec for the FFT or DFT, but I found that that's what you have to do just through trial and error. And then the spec phase offset is equal to the inverse tangent to atan 2 atan 2 of x imag x real. And then I'm just returning spec. Oop. So that's that. Now I believe I can come back here. There we go. I should also start streaming on Twitch. Like dual streaming. But I think Twitch gets kind of hairy when you try and dual stream. So one sec, I'm just gonna open a window because it is lovely and windy outside. Looks like it's also gonna rain soon. Texas needs so much rain. It barely rains here. Which makes me sad. Oft lib wave spec oft lib extract wave spec. And I want to do complex number of ft out ft out I sample rate and array len ft out. So that will pull out the wave specification, and then I just want to printf the spec, and I'll say f m f p f, so frequency, magnitude, and phase, spec frequency hz, spec magnitude, spec phase offset. Actually, is this frequency as in the angle or in hertz? I'm actually curious. Now I'll just make, right, and I have to define those. Define oft lib square root as sqrt. Define oft lib atan2 as atan2. Test. So at a frequency of 0, 1, 2, 3, 4. So at a frequency of 5 hertz, at a magnitude of 3.5. That's interesting. Why is the magnitude 3.5? 5. But yeah, that is correct. If I recall correctly, the wave was, at 5 hertz. Let me see what happens if I don't divide magnitude by n. So instead of, so don't divide magnitude. Now what happens? Yeah, see, now it's like way off. Whereas when I divide by n, it stays the same. You know what it could be? I think it's because amplitude actually carries phase information. Yeah. So now things are back to normal. Frequency 5, 0.35. Let me bump up the sample rate. Sample rate, actually I'll bump it down. I'll bump it down to 20. Test, so frequency of 5, yep, 0.35, so it's the same, good. Now let's see if I can recreate the signal. So I want to check, I want to store the inverse DFT, oft lib complex number ft inverse array len samples, or actually I should say ft out, because I want to say oft lib dft ft out ft inverse array len ft out, and then true for inverse. and I want to do a comparison. I want to say for size t I 0 I is less than array len samples I plus plus. I want to say printf. I want to say f is equal to f, and I want to say samples I dot real and ft inverse I dot real. Now I'm gonna print these. Yeah, so now it's matching pretty much perfectly. I'm actually just gonna make sure real quick. I'm gonna bump up sample rate to 100 again. And I'm gonna say, instead of printing out, I wanna print out the first 10 digits instead of that minuscule. Yeah, so it looks the same. I'm actually gonna do something a little more scientific where I'm gonna do if samples I dot real is equal to ft inverse I dot real and samples, actually I'm going to do an inverted. So if samples I dot real is not equal to ft inverse dot real, or samples I dot immag is not equal to ft inverse dot immag, then I want to, and I'm not doing any heap allocations, am I? No, I am not. So I can just say, actually I'll do something just to make sure I can catch any future heap allocations. Alright, good night. Have a good night. Have a good sleep. Good night. Sleep tight. Don't let the bed bugs bite. I'll see you in the next stream, hopefully. fprintf std error. Uh-oh. Inverse transform all fucky wucky. And then I'll just print out the values. std error 20f. Now I'll print out the actual numbers. So I'm going to do .20f is the real part plus .20fi is not equal to 20f plus dot 20fi. So I'm going to do samples I dot real samples. Oh, and I also want to put a new line. I dot imag ft inverse I dot real ft inverse I dot imag. There we go. And actually, I'll print this in red too. fprintf std error 033 91m 0m. So now this will print in red if something goes wrong, and I'll artificially frick this up too so I can see it in action. And I'll say, I also want to print out the line number. There we go. Now if I make and run, yeah, I'll say, uh-oh, inverse transform all fucky wucky. And it will say at 0, that. Actually, I think I may have messed something up. Maybe, I don't know. I am getting into imprecision territory. Now I'm just confused. Oh. Well, it's not going to equal due to imprecisions, though. That's a thing. Is there... In C, is there a function to see if two doubles are approximately equal to each other? See, there isn't a built-in function or approx. F abs epsilon. Ah. Alright, so I guess I'll just write my own. I'll say static bool double approx. How do you spell approx? Or approximate? Approx. And I'll say double LHS, double RHS, double wiggle room. If abs, dabs, is dabs a thing? Fabs, Okay, fabs does take a double, so if fabs LHS minus RHS, meaning so even if the difference is no, but see what happens if the result is 0 though? That could be a problem. Here's what I'll do. I'll double bigger. LHS is less than RHS. RHS. LHS. Double smaller. LHS is less than RHS. LHS. RHS. There we go. And then I also want to make these const. Const double diff will be bigger minus smaller. And I'll say if diff is less than or equal to wiggle room, I want to say return diff is less than or equal to wiggle room. So if diff is less than or equal to wiggle room, then the two floats are approximate, or doubles are approximate. I think I implemented that correctly. Double approx. Wiggle room. And I just want to do the same on this side too. Double approx. Wiggle room. I hate floating numbers in floating point numbers in computing. They really suck. Define wiggle room. Let's try that. Or like out here. 5. Yeah. Make test. Yes, see now it works. What if I decrease this? Yeah, still works. What if I add more zeros? Still works. I wanna get this to the point where it does not work. Yeah, now it does not work. So I'll start removing zeros. Still does not work. Yeah, see now it's okay. So I'll stop assigning down here. Yeah, and now it runs fine. Good. And I'm just extracting frequency information here. I don't really like the look of this. Alright, see you in the next stream. Good night. Log void and Soli. Oh yeah, I already read Soli's. Yep. Good night, log void. Alright, so I have this stuff and wiggle room. Okay. Now I can do some fun stuff. Now I'm gonna say OFT lib complex number recreated array len samples, and this will instead be recreating yeah, so I'm gonna for size t I 0 I is less than array len ft out I plus plus. I'm gonna say const oft lib wave spec oft lib extract wave spec ft out I sample rate array shoot I sample rate array len ft out. So I have the spec, and then I'll say recreated I dot real is a cosine this time. Recreated I imag 0. And I want to say cosine 2 times oft lib pi oft lib pi 2 times pi times spec frequency in hertz times time minus spec phase offset times spec magnitude. Const double time is equal to double I divided by double sample rate. Right? Yeah. And I also want to make this const. I believe I did this right. I do remember I have to use cosine instead of sine when recreating. Reconstructed. It was up here. Cos to plus phase offset. Also, whoa. The minus and the plus are different thicknesses in JetBrains Mono Nerd font. Or JetBrains Mono font, I guess, in general. Alright. So that will recreate this entire thing. And I want this to be lib. Like that. Good. Now, I just want to print out these. For size t I is 0, I is less than array len recreated, I plus plus. I want to do print f just 20f new line recreated I dot real. Since the imaginary part doesn't really matter. Test. That looks to be generating a wave correctly. Okay. Now I just want to check to make sure that the sample at that given position is approximate. So I'm going to say recreated, I want to say essentially this again, but if yeah, I'm just going to copy this. If samples real or approximate, I want to say instead of ft inverse, I want to say recreated. Like that. Uh-oh. Recreated signal all fucky wucky. Instead of ft inverse, I want to do recreated. Yep, like that. And then I'll just run this. Make test. That's not good. What if I do sine? Minus what's airing? Well, what's this? I don't understand what's the matter. Cosine plus phase offset. What if I just set it to the 0.7? What if I just set it to that? Will it at least work if I do that manually? And I don't do phase offset. will it behave when I do this? Or actually, I will add phase offset. All right. So 0, yeah, it's way off. What the heck? So it looks like it's going down here, whereas it's going up here. I'm gonna, Can I somehow, alright, one sec. Be right back. All right, back. Let's see. Now, Now, well, I don't really know what to do. I think, what I could do is print out like a little true color thing so I can visually see stuff. So down here, I'll say SS. And it will be mark samples, mark recreated. Mark samples 20, mark recreated will be 20. And then I'm going to do printf. And I'm not going to do bounds checking because this is guaranteed to work. Mark samples will be, what is the true color? How do you do true color in extern? Right. It's I want to do 48. 48 to, yeah. 033 48 2, and then I want to do LUR. What is D? D in C. What is actually D? Int. Huh. Or, yeah, so int. M. Right? Yep, M. And then I'm going to, wait, okay, so 1, 2, 3, 4, wait, so this is one character, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, wait, hold on, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. This should still work. I'm gonna bump it up to 30, just to be safe. sprintf mark sample mark recreated. (48) to D M. And these D's will be uint8t const uint8t r samples will be samples, or actually b samples for brightness will be equal to I'm gonna get the wave spec magnitude, and I need to say, oh wait, it's just right there. Recreated, I want to say recreated real times 0.5 plus 0.5, and I want to take this entire thing and I want to times it by 255.0 and then convert that to uint8t. Recreated samples, and then I want to say b samples, b samples, b samples, b recreated, b recreated, b recreated. And I'm going to bump these up to 50 characters. Because I also just realized I need a space and then a 033 0M. 033 0M. So now what happens if I run these? Okay, so I get like a gradient representation. Good. So the wave, so the recreated wave is doing some very strange stuff. Like, what the heck is going on? That is kind of odd. Yikes. Also, can I tell C, can I do something like this? 4. No, I cannot. So why would it be doing this? That's my question. Also, I'm going to separate these visually a little bit. All right. What could I be doing wrong here? So, I'm assuming that's correct. I must be like not initializing a variable or something, right? I know this function returns correctly because I compared its output. Cosine OFT lib. Maybe it's this? I don't think so, but no. What if I do that? No, that really didn't fix anything. What are all these, like, weird artifacts? Phase offset. Spec magnitude. Make test. So now it's just gray. What if I turn down the sample rate to 20? Well, I get something. It's still not working though. What could it be? I know that works. Yeah. Alright, what happens if I simply just remove that N again? Well, that wasn't it. But it is a start. Oh wait, what? It looks like I'm just taking the output of the DFT. Whoops. Perhaps that's what it actually is. Well, let's see. Okay, I am using recreated. I don't understand OFT lib extract wave spec FT out. OFT lib extract wave spec FT out. I just realized this should be FT out. Hey Elseka, how's it going? How's it going? Wave spec. Not as amazing. Not as fucking amazing. Just... I'm stuck. I'm trying to figure out the discrete Fourier transform implementation for my library. I already figured out how to do the transform on my mom's laptop. I even, like, figured out the Cooley-Tukey FFT and stuff like that. But having issues putting this back into C. Cosine left lib pi, unless the pi is wrong, but I think pi is fine. Yeah, because I'm using pi in the actual library itself. Yeah, I actually stopped programming in Rust. It finally drove me over the edge. I was already beginning to have my doubts about Rust, but then, like, they allowed you to delete your own crates on crates.io, even if tons of projects depended on them, and that was the moment that I was like, no, I'm gonna leave Rust. Also, I cannot stand the Rust community. And I'm really enjoying C. It's actually, like, I'm a little upset that I didn't touch C sooner, but I am glad that I have a Rust programming experience, because now I can write safe C code. I don't understand these phase offsets. What the heck? I don't like C++. Like, it's not because it's an OOP language, but it is because it's an OOP language. Mainly as in, I don't mind the fact that they have OOP features. What I do mind is if I want to use anything useful from the C++ standard library, like all these things have weird exceptions from things like templates, and the fact that even when it seems like something is a function or a struct, it's actually a class. And then also the fact that OOP is slow. Like, you have to do a bunch of fat pointers and stuff at runtime. And it's not good. So I try and avoid C++ as much as I can. I actually ended up making my own library that adds vectors and hash maps and stuff like that to C. What am I doing wrong? This is what I want to know. Spec. Seems correct. Yeah, there's that too. I've heard people say that C++ is not a great implementation of the OOP paradigm. I just don't like paradigms in general, unless it's something simple like Rust's paradigm, where it's just regular old structs, but you have traits for when you want to do generics. Rust's paradigm is my favorite. Ugh, why is this happening? It's literally just giving me the exact output of the of the DFT, just scaled down. Bruh. Oh, I think I might actually know why. See, I'm recreating the samples incorrectly. Whoops. I actually need to do I need another for loop. I need to say for size tk is 0k is less than array len ft out k plus plus. And then I need to do this, where do that, and then the wave spec is out here. ft out k sample rate ft out. So that will, and then what I need to do is, yep, that. Okay, I think I fixed it. I hope. It's gonna be a lot slower now. Or maybe not. To both. I actually really like the C syntax. It's very descriptive. Well, then again, to me, as a programmer and not a coder, syntax actually doesn't matter to me as much as to a coder. So, well, I don't mind C syntax. I think it's simple, elegant, and easy to use. Now, I'm trying to figure out, what did I do in my P5 sketch? Recreated. Reconstructed, if, draw, stroke. Well, that's not what I wanted. I wanted, function draw. Where am I recreating stuff? Reconstructed length, push, reconstructed push. Oh, I'm being stupid again. Instead of this, I want to do sample, double sample, 0. Recreated I, real, sample, recreated I, mag, 0.0. And this needs to be k. And instead of this, hold on. I might have this backwards. Yeah, I need to do for size t I is 0, I is less than array len recreated I plus plus double sample recreated I dot real sample recreated I dot imag 0.0, and then I need to do for size t k 0 k is less than array len ft out k plus plus. And then I need to do const oft lib wave spec oft lib extract wave spec ft out k sample rate array len ft out. And then const double time is equal to double I divided by double sample rate. Yeah. Sample plus equals cosine 2.0 times oft lib pi times spec frequency in hertz plus spec phase offset times spec magnitude. And then I just need to delete this. Yep. And, oh, not using time. I need to 2 times pi times frequency times time. There we go. There, now it matches. Let's go. Oh, man. All right. Test. Yeah, see? I have perfectly recreated the signal. So that's essentially how the audio upscaler will work. So now I will remove this continue. And it passes. It actually passes. Cool. So, but that's only half of the story. That's just the DFT. So I'm not done with this project yet. I haven't even gotten to the actual audio upscaler application. I'm just working on the FFT DFT library still. Yeah. Now, so that's all the like FFT list items. So this works, but now I got to do the DFT, or the FFT, sorry. So instead of oft lib DFT, I need to do oft lib FFT. And then, yeah, so FT out. Yeah, I'll just make sure samples is a power of 2. Let's see. Here's what I'll do. I'll just define it up here, 2048. That should be more than plenty. 2048, 2048. And I'll do down, up here I'll do, instead of Fourier transform out, I'll do FFT count. Now that we know the DFT works and stuff. So OFT lib FFT, I'm doing, takes an input, performs either a fast Fourier transform, inverse fast Fourier transform, size T, input count. Yeah, so input count like that. Good. And did I specify? Yeah, I did. And then down here, I also want to say FT inverse. Okay, yeah, so that works. OFT lib FFT, and then I just want to say array len samples approx FT inverse. Okay, that all looks good. Recreated FT out. Actually, for recreated, I'll just do samples. For Raylan recreated, FT out, and yeah, that will work just fine. And I should actually say, instead of here, I should do FT count. Array len FT out. FT count. FT count. FT count. And the reason I'm doing it like this is because FT, the length of the array FT out will not be the same as the count. Const size T FT count will be equal to OFT lib generate PO2 more or EQ2 array len samples. So now that should work correctly. Meaning the only thing now I gotta do is implement the FFT. How long have I been streaming for? 3 hours. Alright, I'll keep going. Also, I'll write a little description too. The fast Fourier transform, fast Fourier transform, the Fourier transform and the Fourier transform is an algorithm, is a mathematical expression that has the ability to dissect a signal into into its individual sinusoidal frequencies, amplitudes, and phase offsets. On the other side of the coin, there is the... I don't really like that wording. There is also the inverse Fourier transform, IFT, on the other hand, takes in the output of a Fourier transform, FT, takes in the output of a Fourier transform, FT, and recreates the original signal from it. I'll also link a 3 blue 1 brown video. Really good 3 blue 1 brown video about it. Fourier transform. Yep, okay. Sweet. So, linked the 3 blue 1 brown now, time to actually implement the FFT. No more stalling, let's get started. Which, first I'm going to start by looking at my sketch. So, let's see. FFT samples inverse. Right, and then I have an internal, so same thing, except static void OFT lib FFT internal coolie tuki. Coolie tuki. Yep. Good. Spelled it correctly. And it will have the exact same function signature as the FFT. The actual FFT implementation, but it expects that the input length is a power of 2. Thus, there is an OFT lib FFT function to wrap it. To handle input that isn't a power of 2 in length. So now I essentially have to say, where is it? Yeah, FFT original length samples final. I essentially need to pad. That's what I need to do. So, dang it. I don't want to use malloc or anything like that. Let's see. What can I do? I could handle it to where the internal FFT function just returns a 0 if out of bounds. I think that's what I'll do. So first I'll say I'll create a OFT lib bool t is PO2 input count. OFT lib is PO2. I'll just say OFT lib bool t is PO2. Actually, perhaps I don't need that. So I want to say, I want to pass all the parameters. So input, output, input, count, right? Input, output, input, count, and inverse. Now I just have to oft lib uint max t input count po2 oft lib generate po2 more or eq2. Input count. All right. Yep. So there we go. And then I'm gonna. The heck? I want to. FFT internal let n samples length. If n is 1, return sample 1. If input count po2 is equal to 1, then return oft lib access input access fft input. An internal function that returns a zeroed out complex number if trying to access out of bounds of an FFT input. Static oft lib complex number oft lib access FFT input. Static inline. And I don't want to return it. I want to output no, dang it, frick. This is going to be challenging. I think. Maybe not. Okay, so when I return from an FFT internal, let me look up the Cooley-Tukey FFT. Light's easier to read in for dense. No, but it hurts my eyes. Right, so this is going to be a bitch to implement. Here's what I'll do. Cooley-Tukey internal, like the FFT internal Cooley-Tukey, will take an offset. Offset. Zero. Because this function will actually be recursive. And I want to say, dang it. I think I just want to say output offset is equal to input OFT lib access FFT input const OFT lib complex number input restrict input size T real input count. Actual input count. And I want to say if, and I want to pass in an index. Size T index. I want to say if index is less than actual input count. Right, so say the input count is 1, index 0. So yeah, return input index, else return a complex number. OFT lib complex number zero point zero zero point zero. Yep, okay, so like that. And then I just want to say input 0 input count, I believe. All right, let me go back to my sketch. Samples, yeah. And then I just want to say Oh. This is gonna be challenging. Because I just realized, oh fuck, I can't exactly create another array with a variable length. Crap. Let's see. Instead of offset, this parameter could be skip. No, I'll have offset and size t skip. I'll do oft lib complex number odd is equal to all the odd spots. No, I need to run in recursive oft lib fft internal coolie tuki. I need to say the offset is 1, or offset, no, offset plus 1, yeah, maybe. Size t, and you say the skip is skip plus 1. The input is input, the output is output, and oh my god, this is so much harder in C. Alright, here's what I'm gonna do. I'm gonna give my brain some time to internalize this, and then I'm going to implement this. Supertext cart time. Also, the mic might be picking up feedback from my speaker since I forgot my headphones again. Oh. I also need to bring the chat over. Uh-oh. There we go. Nope. Let's see, what else is there? Remember, oh, it's raining outside, so Raven Bridge Mansion would be a good one. Yeah. Frick. Not getting any of the nitro. Yep. Alright, back to figuring out the FFT. Let me draw it in GIMP. So, new. So let's say I have my inputs. And for right now, I'm not going to worry about if they are not a power of 2 or, yeah. So, then I have my outputs. And, here, yep. What do you mean? I'm on... So I have my outputs, and then what I do is I have two Fourier transforms, or DFTs, or recursive calls. And these take in, this one will take in all the odds. So, wait, no. We'll take in 1, 2. So we'll take in all the odd indexes. And then this will take in all the even indexes. And then, once I have that, each of these will call their own inner thing. Also, I'm going to spread these out a little more. Like there. Yep. So these are even. And then these are odd. And then I need some more, like this. So it's a recursive thing. So from here, all the evens go to this even. Yeah, so, but then all the odds go here, even, odd. And there's only 2, yep. Even, odd, even, odd. And then there's some fiddly, well, these first of all call to more. O, E. It's not a very good E. Yeah, that will work. So more of these. And actually, I'll redraw this just to... odd, even, and then I'll copy. Still too big. Well, basically, odd, even, odd, even. There we go. So then these internal, like, recursive calls, those get handed to, so from odd, so even, odd, even, odd, even, odd, even, odd. And then there's some weird fiddly stuff that goes on to essentially merge these back into the thing. But I need to figure out... See, this is where I'm drawing a blank. So what if I color all these so I can see their paths? So that's not what I wanted to do. Let's see. So what if I... all of these will be red. Actually, what I'll do is I'll make a tiny little... just cut that, cut that. So I'll do like this. Ooh, it's raining outside. Not a lot, but it's raining. Okay, so now I have this. Now I can color this red. And this will be yellow. No, I'll do blue. I essentially just need to see right now I gotta do the same kind of thing here. So slice that up a little bit. And I'll go ahead and slice here too. Alright, and then I'll fill in some more colors, so I'll do an orange. Actually, that's not too friendly to the colorblind viewers. Now let me separate this. There we go. So this will be pink. And then I want, what else? This. It's like a yucky yellow. No, I'll do green. Green, that's also a really horrible green. I'll do yellow. So this is yellow. And then I want an actually decent green. It's also not too colorblind friendly. Purple. And then I'll just keep that one the same color. And then what else? What other colors can I do? This is where I gotta start experimenting a little bit. So I gotta make like a little brown. Something like that, maybe. So that's brown. And then I want like a green like this. Yeah. And then a really dark blue. It's not contrast enough. Something like that, maybe. Yeah, that works. And then, I'll do a white. Yeah, I'll do a white one. And then a really dark gray. And then a slightly lighter gray. Oop. Like that. No, that's not light enough. And this is where the programming project devolves into a boring art project. Light reddish pink. Something like that. And then I want this peach color, this tan color, and then this bright, no, that's the same color. What if I do like, do I have a color like this? No, that seems to work. Okay, so how does this feed back to the input? It's let's see. Oh, why is this so challenging? Well, can I figure out... let me figure out... I'm gonna do something. So this goes blue, 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 and this goes red, 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 red. And then after that, like this point, for example, goes to here, it appears. Light blue. And then after that, it appears to go to here. And then this one goes from here to here. And then from there to here. Meaning I can make these bigger. Not like that, but 11. That could work. Actually, I'll just line these up. Ah, frick this. And then, right, and now I'm just gonna fill these in. Like that. Wait, hold on. Okay, wait, so this then becomes the even input. Wait a second. It stays even. Okay. Stays even. Yep, alright. So even input becomes even. And then stays even. I think. And then here, this goes here, but this time it's an odd input. So it goes here. But it's an even input to the odd input. So it goes down here. And I think I might be doing something incorrect. Shoot. No, I'm doing stuff correctly. Even. And this one is odd. So it gets put. Wait a second. No, it goes here. I think. Odd. So it's going there. Yeah. But then it's even. Let me verify this. So here, here, here. Okay. Red. Here, here. Blue. Here, here. Okay. Red, here, here. Okay. Aha. Alright. So then blue here. This is like a very annoying puzzle here. And then here, here. Here. And then here, here, here. And then here, here, here. Uh-huh. So let's say I want to, and let me make this a background that I can actually focus on. Like that. There we go. So, ooh, whoops. Ooh. Let me choose a lighter color, or darker. Darker. There we go. So let's say does white, so yeah, white is guaranteed to come back here. What is the relationship? I don't get it. So like for example, purple, that one gets stride of 1, so skip 1, offset 0. And then purple gets offset 2, stride 1, 2, 3. Same with the blue, except the blue stays, yeah, same offset, no. What I don't understand is how would I implement this in an array-based approach with pointers as opposed to returning arrays? Oh boy. So if I were to work backwards from this, so I have like my 8 deepmost transforms. I need to look at the Cooley-Tukey diagram. Or what about the code here? What the heck? Oh my god. Alright, so shit. Well, first off, move this to out here. Make it const. Instead of the Cooley-Tukey, OFT lib size t input count PO2 OFT lib size t input count PO2. This is hurting my brain. Let me look at my FFT internal here. So output. So output, I'm saying, is a block of memory essentially. Yep. So I guess what I could do, man. This is, stuff like this is so annoying. You know what? This is, I'm gonna ask AI. I'm not gonna copy paste any code, but I just want to understand how the hell I do this. How can I implement? Can you help me understand how to implement a Cooley Tukey FFT algorithm that recursively calls itself, but instead of returning an array, it modifies an existing pointer to an output array. I am working with C. Alright, let's see what it gives me. Original array. Combine using butterflies. Fuck. Okay, so I have the complex number, right? Cooley Tukey FFT. Complex input, complex output, int-n, right, so I have a stride, so I was on the right track. Base case size 1. If n is equal to 1, output is interesting. So I'm dereferencing. So I'm going to say if input count PO2 is equal to 1, I want to say output 0 is equal to OFT lib access FFT input, and I want to say input 0 input count, like that, and then I'm just returning. So I guess that sums up my confusion. Base case. But otherwise I want to say angle. What are you doing here? That's interesting. Oh, this is just you're not even, oh, you're doing it up here, I see. Input plus oh. Half n. What are the parameters? Complex out input. Well, you're... What? OFT lib access. No, OFT lib FFT internal coolie Tukey. This seems wrong. I'm gonna see if I can find coolie Tukey algorithm in C. Maybe this is what I need. What the fuck? Okay. What is this Alright, let's see. Why can't I just be... Who let mathematicians write coding examples? Oh, maybe this will help me. What is this? Huh. FFT size. Half n. Here's what I'll do. OFT lib size t input count PO2 half is equal to input count PO2 shift by 1, just to be performant, in case whoever's using this library is not using optimizations or can't use optimizations. And I just want to say, and I'll add a comment here, divide. This will be even. Odd. Stride. And I'll say is it times 2? What was it? Input plus stride. Stride times 2, yeah. So shift. Input count PO2 half. And then I'll say input, what was it? Yeah, input. And for odd, am I doing the second or first half? It doesn't tell me. Fucking cheater. I guess I need to create my own function that's like, crap. Let's see. I'll figure it out. Yeah, I'll create a slice. Typedef struct oft lib slice. It will have oft lib size t starting index oft lib size t stride and oft lib length count or I'll say length. Element count. And then I'll say static oft lib slice. Oft lib slice. No. Oft lib complex number. Oft lib access slice. Or let's see. Size t. Oft lib size t. I'll say access slice oft lib slice resolve slice resolve. Internal function that take an index and transform and convert it based on a slice. So I want to return, I need the index, oft lib size t index, and I want to say return index times stride plus start, I think. Yeah. And I guess length is irrelevant then. oft lib slice resolve. There we go. Static inline. So instead of input, or actually this will take input, but it will also take a slice. oft lib slice. Nope. I want to OFT lib slice. What did I do? Oh, I have caps lock on. Slice. And I want to do OFT lib slice resolve 0 slice. And then I want to also do static const OFT lib slice OFT lib slice identity, like an identity matrix kind of. OFT lib slice a slice that does nothing to the index. There we go. And then here I just want to say OFT lib slice identity. Yeah, like that. And then once I have that, I want to do in here. I'm not going to add these just because it is confusing me a little bit. I'll add more comments to this when I'm done. Give birth to children. So the even slice. Oh, okay. So I actually will comment. So I do know. Okay. So std slice even, what was slice again? C++, starting index, let's try it. I need a better example. Example of how to create an std slice in C++ that starts at index 5 and has a stride of 3, let's say. Just want to see the positional arguments. Okay, I see. So even starts at 0, has a stride of 2. Size, okay, so it's just oh my god. So okay, instead of stride being there, oft lib stride even equals oft lib stride. Just gonna create a wrapper macro, or not stride. Slice. Define oft lib slice p start p stride. P start p stride. Oft lib slice 0, 1. All right. So the slice starts at 0 and has a stride of 2. It doesn't seem right. Let's see what happens. Actually, yeah, that does seem right. No. Fuck. Alright, let's see what happens. So that's also, wait, no. So it's starting, no, okay, it does work. Wait, what? Oh my god. Okay, I'm gonna create some types just to make this a lot easier. So slice will also store OFT lib complex number. No. It will be a resolver. It's annoying when stuff like this happens. Man. Okay, here's what I'll do. I just wasted a ton of time on this that I'm not going to get back. So I'm just not going to implement the FFT for now. And instead, I'm just going to use multi-threading. Or something similar to that. What a waste of time. Coolie, two-key, FFT implementation. Not done. Done. Being worked on. Unsure if needed. DFT implementation. Oglow's Fourier transform library version v 0.0.0. I'll do like that. And I'll do that. Does MIT say copyright? GitLab.com/crates2GUI, for example. License. Copyright C. $2025. Yep. DFT. ArrayLen samples. FT out. DFT. Const size TFT count is equal to array len FT out. Our samples. Change for when the FFT is used. Make test. Okay, so I've got the DFT implemented. This is not where I want to make a Git repository. This is. Yep. Git remote add. I'm gonna cat include less and copy that. Git remote add origin. There. Dang it. Well, I'm not signing in on stream. Guess I'm gonna create it on my phone. Fucking GitLab always signing me out. Okay, create new project repository, create blank project, oft lib, oft lib, public, initialize with a readme, sure. And then add license, apply from template, MIT. Commit changes. Commit changes. So now I just created the repository on my phone. Git pull origin main. License. Readme. A library for C. A library written in C in C99 for performing Fourier transforms and inverse Fourier transforms on data. Oh, I should also specify it has no external dependencies and doesn't use the C standard library. Thus, it can be used in embedded environments too. There we go. Get status add readme, or get add readme, get status, get commit -m, updated readme.md file. Get push-u origin main. Get push -tags. Get status. So now OFT-lib is on the internet. Cool. And I'll have to add FFT support to it eventually too. Alright. Alright, I'm getting tired. I'm gonna stop the stream now. In part 2, I think I'll actually implement the audio upscaler. Bye-bye. Have a good day.